Hello. So I tried to also add, explain the stuff related to my research when I have time. So a part of my research is about accelerometers, designing accelerometers, and also application of accelerometers. So, but how accelerometers work in principle? If you think about it, if I have a mass, so an accelerometer is, in general, an accelerometer is composed of a mass, an elastic support, and a rigid frame. If you think about it, if I have a rigid body, if everything was rigid, so let's say that I had this rigid frame, apologize, I'm sorry. So if I have this rigid frame on this mass, let's say I connect this mass to my rigid frame using a link, a rigid link, then you can easily see that if this frame moves, the mass would move with the same displacement and acceleration. Sorry. Now, however, if I introduce elasticity into this system, somehow I use a spring instead of a rigid link, then you do intuitively understand that physically speaking, the displacement and acceleration of this mass would not be the same as the frame. So the frame moves up and down, for example, and the mass, as the mass moves up and down, the spring also compresses and decompresses, and this is a damper. So you do see that all the time there is a relative displacement. Once we introduce elasticity, either we suspend the mass using a beam, for example in this case, beam, using a suspending beam, or using other designs, the displacement of the mass and the displacement of the frame would not be the same. Now it turns out, and you can also understand that, all right, so what does this displacement related to, or what is it related to? Meaning that, all right, so we have the displacement of the frame or acceleration of the frame, and we have the displacement of the mass. But you do understand that this displacement and the relative displacement depends on the spring, how stiff the spring is, the mass, and it also depends how strong this external acceleration is, right? So it turns out that the relative displacement can be related to external acceleration. So if I plot the external acceleration versus relative displacement, I see a line like this, for example. Let's say we have a linear relationship between the two. Whatever the relationship is, there is a direct relationship between the external acceleration and the relative displacement. So if we calibrate relative displacement versus external input acceleration, then we can use this calibration curve to identify external acceleration, right? So if I take this acceleration to the lab and I devise this calibration curve, now I have this calibration curve with this accelerometer. Now if I give you this accelerometer and say, all right, now use this accelerometer and go measure the acceleration of the machine, of that launching pad for that spacecraft, then what you are going to do is, all right, you're going to say, all right, so you somehow measure the relative displacement and you come to this calibration curve and read the acceleration from this calibration curve. Now in practice, this relative displacement is related to some other variable, a voltage, mostly used. And what happens is, for example, they're gonna say, all right, so we're gonna place an electrode here, and because this mass goes up and down, that change in capacitance generates a voltage. So they draw a second curve and they relate the relative displacement to the voltage. So now you have everything you need, because once I give you the accelerometer, you do your test in your system, you read the voltage, you come to this curve, you read the relative displacement, you come to this curve, you read the external acceleration. And this is the basic principle, operating principle of accelerometers. So I try to talk about topics related to my different topics that I research about or work on when I have time. Thanks for paying attention.